Last week, during a string of clear summer nights, I set up my 200 mm f/5 Newtonian reflector in the backyard. I wasn't expecting to discover anything new, just hoping to gather high-contrast data on emission regions near the Serpents, Aquila border. But while scanning along RA 19 hours 7 minutes and DEC plus 1 degree 53 minutes, I noticed a diffuse, reddish structure that didn't correspond to any major entries in my star charts or imaging catalogs. I decided to track it further. Over the course of 2 nights, I gathered a total of 6 hours of exposure using a dual narrowband filter centered around the H-alpha and OI lines. The resulting stacked image revealed a compact but well-defined nebula, elliptical in shape, with a slightly denser central region and asymmetric filamentary extensions. Initial analysis suggests the object is most likely a faint planetary nebula, possibly in the late stages of its evolution. Based on angular size and estimated extinction in this region of the Milky Way, I estimate the nebula lies roughly 8,200 to 8,600 light-years from Earth, likely residing in the Sagittarius spiral arm. The nebula spans approximately 2.9 light-years across, with a total integrated flux in the H-alpha band of around 2.1 times 10 superscript 1 cm superscript 2/s. The central star, though faint, is detectable in stacked frames, likely a white dwarf with an approximate temperature of 30,000 Kelvin. Its apparent magnitude is near 19.3, making it challenging to resolve without long exposures. Spectroscopically, the nebula emits primarily in the hydrogen alpha line, giving it the reddish hue visible in the processed images. There is minimal detectable OII emission, which is consistent with a nebula whose central star is no longer generating strong ionizing radiation. This would support the theory that it's in a post-peak phase of ionization. The morphology is particularly interesting. The outer regions display signs of Rayleigh-Taylor instabilities, suggesting the ionized gas is interacting with the surrounding interstellar medium. There's also a noticeable brightness asymmetry from north to south, which may indicate a density gradient in the local environment or anisotropic mass loss during the progenitor's late AGB phase. While this object doesn't appear in major databases like the Sharpless or Able catalogs, it may simply be too faint or too small to have been previously classified. I've tentatively designated it PNJ 1907 plus 0153 for my own tracking purposes. This find reinforces how even small, backyard-class telescopes can contribute meaningfully to observational astronomy, especially when paired with careful planning, narrowband imaging, and a willingness to document anomalies that might otherwise go unnoticed. Future observations with a larger aperture or professional spectrograph would help confirm its classification and refine its parameters. For now, though, it remains a quiet, fascinating object, a dying star's last whisper, glowing faintly in the dark.